What's up, everybody? All right, so I actually streamed yesterday for quite a few hours, and towards the end, we were trying to figure some stuff out. We kind of figured out like what the workflow of WebRTC looks like, and started like looking at an example that's in the GStreamer examples library on how we can implement that. But it turned out we have a lot of issues inside of our kind of the design of the switcher itself and how to fit that in. So Giuseppe finally generated. Good morning. Good morning. Thanks for joining. So yeah, and if you happen to be here last night when I demoed for the Raiders and the Azure stuff wasn't working, it turns out it wasn't an Azure issue, it was an Eric issue. I forgot that I had leaked my keys on stream and I had rotated them. So the issue was really that my containers couldn't spin up because they couldn't communicate with the registry because they didn't have the right credentials because I had rotated them. At least I remembered to rotate them. So trying to figure out where we want to get started today. I really want to make some headway on WebRTC because I think this is going to be ridiculously cool. But we sort of have a couple of issues. So if we break out our diagram here, we kind of have the difference between like an input and an output. Well, the issue really is that WebRTC is both an input and an output. So we have some shared logic that we could, build a shared library and then create an input type and an output type, and they could share some code. But then we create this situation where we can't use WebRTC as both an input and an output. And I'm trying to think, do we have a direct need for that right away? I don't know. I'm just trying to think of what that might look like, right? Well, I suppose it could work in the sense that if you were a broadcaster and you were doing some sort of shared stream, say like we were all kind of guests on the same thing, I would be able to take your input, put it into the switcher, and then also send back everything. I mean, you'd hear an echo, right? Because you'd hear yourself in it. But I mean, in theory, right, you could be fed the stream so that you could see what everybody else is seeing. And that could be useful. Yeah, okay. So, yeah, so the idea here is that we need to figure out how to do this. The second issue is going to be, this will be like my first foray into like trying to really do threading and, the notion of channels and things like that. It's heavily done in the example that way. So we will be learning that at the same time. So I have the feeling this is going to be a lot of banging my head against the desk. And you all get to witness it. So one thought that I had here was sort of like, where does this all live, right? Do we manage WebRTC connections in a mixer and then connect them? But the more I think about it, the more I kind of feel like it should be at the same level as a mixer. Because then what we could do is we can create a WebRTC connection, and then we can link our streamer to the input, right? Or we could link our mixer to the input. So we could manage like one individual WebRTC connection and then use it to preview this stream, use it to preview this stream, use it to preview the output. Dota2 Attitude, how's it going? So that's sort of my thought. If they were managed separately, then we could just keep moving around what it's connected to, right? And so in order to do this, though, what we need the ability to do is have a source element be able to be linked to more than one output. So we've already got it on this side, right? but we need it on this side. We need to be able to take an input and link it to multiple things. So we're already kind of doing that with the notion of recording, but we don't really have anything like in the mixer or on the input that says, hey, I want you to send your feed to multiple things. So we just have to think this through from a design perspective first, and then we'll try to figure out how we're going to, then we can start looking at implementation. Buala, is that how you pronounce it? Thanks so much for the follow. So this is sort of my thought here. And I guess if we take a look at, like, let's just look at our URI input. We can see where our record logic is. Where's our record logic? Okay, so this is just it's been a while since we wrote this. Okay, so this is creating the config for the output, right? It's creating that's going to be ultimately used in the file output, right? So here's our file output create. Okay. And that's being put in here. Okay. So then at the time we link, we basically say if there's one in there, we're also going to link that to the pipeline. Okay. So we basically want to do something similar here, but I think that this is going to get confusing. Well, because we call link on that, we're linking it to us. So it's basically the sync is always responsible for the link. No, because we also link to a source. The sync asks the source to link to itself. And in this case, we're going the other direction. So that's not quite. My thought here is that, like, maybe we potentially need an additional type called a link or something, which has audio, which is a GST element, and video, which is a GST element. So we just have to kind of think this through, because the idea here is that now this URI may need to manage multiple links. Right? Because we could ask it to link to one mixer or two mixers, or... But do we need to manage this, right? Because in theory, right, on link, right, function link, on link we're passing in the pipeline that this input is ultimately going to be a part of. And we're also, so that all of the elements can be added to it. And then we're also passing in the audio and video elements that we want this to link to. So in theory, right, we also, okay, so unlink, we are not doing that. So another option could be if we change this interface so that unlink took the same thing as if unlink took the same thing as link did, then we would know which elements, right? Because we could basically just grab the peer pads there to figure out which one we have. I'm just trying to think here. Do we need any additional elements? I mean, if we did that, one way we could test this would be to remove the record logic up out of here. So maybe we start there. Okay. I've got this giant WebRTC file here that, well, I guess it's, we have stuff commented out, so that'll be fine for now. I don't even know what's in temp. Okay. So I guess let's start there. It's either that or we just play with WebRTC and start trying to build in all the WebSocket stuff. Okay. What am I doing? Okay, input mod. So here we want to look for our unlink function, right? And so this would end up taking the same parameters as link. And I'm just going to fix this one for now. Pipeline, audio, video. We'll have to come back and edit the other ones, but for now this is what we're going to do. Alright, and then we got to find all the places it breaks. Mixer mod. Okay, so here's where we're going to try to unlink. What are we passing into link? Audio mixer clone. Oh, that's not gonna work. Not gonna work. So the reason for this, the reason it's not going to work is we're passing in the mixers. This is an audio mixer component and this is a video mixer component. We're passing those in, but they're creating multiple pads. So if we pass those into unlink, we don't know which pads are which, right? There's going to be a number of elements attached to it, right? So we assume that this input is keeping track of all its own elements and which things are connected to it. So we are going to have some sort of type that manages those connections. All right, so let's try to think this out. So we need something like a pub link. Struct link. Marco, how's it going? So we need to keep track of this link. And I guess we would keep track of what this element is on this side. Okay. So yeah, right now we're trying to do some refactoring so that we can fit this into the chain. So basically we basically have this notion of a mixer for both audio and video, and we have input components and output components, but we're in a situation where WebRTC is going to be both an input and an output. And we also have now, so that's one issue. The other issue is that we may want to take this input and send it to multiple outputs, right? So we're going to end up having the mixer pull from here, but we may also want to connect it to WebRTC so that we can preview what's going on here. You want to add also the chat. I don't know whether I don't think we're gonna mess with the chat yet. I think it's mainly gonna be for video. So we're gonna use it for, so far we're gonna use it for two purposes. So one is that we want to be able to preview what's coming in on an input, right? So we basically create like a production system. Wise old bird, how's it going? So yeah, we want to create like a preview. The other thing is that we might want to actually go the other direction. Whoa. We may actually want to go the other direction where we bring WebRTC in as an input so that you could join from a browser. So those are like the two immediate use cases we're trying to figure out. But I need to figure out how we're going to refactor. So, how are we going to do this? I guess we need to talk all this stuff out. And let me know if you're new here and you don't know what we're building, or you're not familiar with kind of like how video streaming works or how WebRTC works. We can kind of talk all that stuff out. But yeah, right now we're just trying to figure out how we're going to reorganize our code base to manage, one, the fact that this can have multiple outputs and we need to manage them. And two, how do we make this element be both an input and an output? And I think the answer to number two is that we manage it completely separate, the same way we do a mixer, where we just create this. So okay, sorry. I've got a bunch of stuff going on with GopherCon right now, so I've got, you know, messages coming in and things. Okay, so I did a really good job of confusing myself last night, so I'm gonna try to not do that today. So I'm just thinking here. So really, maybe this should be a pad, right? Because we do have the notion of like this releasing of the request pad. So we are, am I not calling this from anywhere? Wait a second. That's not good. Oh, it's duh. So this is it's a shared function. Release request pad is here. So here we're giving it the element on our side and asking it to release it. So then it travels back up and releases it from there. Okay, so how do we want to manage this? How do we want to manage this? So we're going to assume any side that has multiple connections is a T of some sort, right? So this works in the sense that we can take our element, find its source or sink pad, depending on the type of element this is, and then we travel, we grab its, like, say, source pad, and then we travel up to its peer, which ends up being on the mixer side, and then we release the pad from there. So what we really need is the element on our side. So as long as this represented the side that is not the T, right? Okay, what if we... I'm just thinking here, what if we returned a link? So what if here, what if this function returned back a link? And that's what you kept, right? Because the link is all you would really need. Then you would tell the link to unlink itself, right? Well, no, because you still might want access to be able to change configs on it, so that's not going to work either. It's funny, this is like more confusing than it should be. I'm trying to think it through a little bit more because yesterday I did a bunch of like, let's just attack the problem. And then I ended up throwing away my solution. Like, I don't even know how many times, at least 3 or 4. Just to ultimately go with the thing that I was trying to avoid doing to begin with, which is pretty amusing. If we tracked both the source and the sink on the side of the link and we managed it separately, would that work? And then I guess each type could manage its inputs and outputs. Like internally, it could have a structure where it keeps track of its own links. But then when we called unlink, what would we be doing? This would be so much easier, I think, if they were all their own pipelines, but we had a lot of problems with that as well. Okay, so what if I mean, we could manage inside of our inputs, we could manage names of links and things like that. I kind of feel like I picked the wrong feature for a Monday. Okay, how are we going to design this? How are we going to design this? I mean, thus far, I kind of like it. I mean, there's a few things about the design that I don't like. We just have to figure out this aspect. It made sense when you were only ever going to link one thing. But I mean, in theory, we could call link multiple times. The difficulty is only going to be in the fact that if when we go to unlink, we don't know which sync that you want to unlink it from, right? Right now, we assume that you want to unlink everything, that this entire input gets shut down, but that's not necessarily what we want to do, right? And so the other thing we're going to need to do is we're going to need to add a fake sync to this too. So because we don't want to break the flow, so why not C++? I don't know C++ very well. I've only messed with C++ minimally in my career, so it'd be a lot of learning for that too. So if I have to learn a language, Rust seemed like a good one to learn. Yeah, so actually, most of the stuff I'm using is all in GStreamer, and GStreamer is written in C. So, and the bindings for GStreamer were really amazing in Rust, so that's why I went this direction. But right now, I'm not really running into language issues. I'm running into kind of architectural design issues. How we want to do this. Okay, so how do we want to manage this? I mean, we could generically create kind of links and manage links. But who keeps track of the inputs and outputs? No, because we still need access to them. Do we name them? All right, let's All right, let's just sort of think this out. So we have a struct. We have an input, right? We have an output. Then we have like a weird type, which is like WebRTC, right? WebRTC. And this is an input and an output. I mean, I suppose we also have a mixer, but a mixer kind of holds inputs and outputs, but also is one. Okay. So maybe we have the wrong direction here. So right now, a mixer has inputs in it, right? And outputs. And then we ask the mixer to add an input. So maybe this is the wrong way to go about things. I'm starting to think that what we really want to do is have our app, right? It's going to have inputs, outputs, mixer, right? And then we would just call .link, pass in the mixer from here, right? .link, pass in mixer. or input, right? I mean, we could also go this direction too, right, for the output. So mixer link, I don't know, output. Well, would an output have a link? I'm just thinking like the flow of data. Do we always take the source and link it to the sink? I guess that would make the most logical sense, right? One day Clippy tells you to use lazy evaluation, now it tells you not to. Yeah, Clippy hates me, I swear. I swear Clippy hates me. So this might be a good approach. If we pull everything in the mixer up. I mean, we're gonna have to gut like this whole app for this, but because then we could also have WebRTC here, right? And then WebRTC would be able to be passed into an input as a sink, an output as a source. Well, no. A mixer as a, because a mixer would serve as both a source and a. Enum's variance constructors are rather cheap. Fun fact, a tuple variant is not too different from just a function new self. I'm not sure what you're saying here. In fact, you can use them the same and even pass them around as function types. I don't think I understand what you're saying. Chat is hard sometimes. Enum a foo I32 is like function foo I32a. Oh, interesting. And you treat them almost the same at a generic layer. Huh. So I'm thinking we do this, like add sync, right? Add, well, no, because an output is only going to be able to have one source. So this one's special. I don't think an output should have anything. Well, I guess it would be link source. What does this API look like? Mr. Demon Wolf, welcome. Thanks for the raid. Okay. So right now we're just kind of rethinking the design of the application so that we can start supporting multiple connections. And so I don't know what this API looks like yet, but this is sort of what I'm thinking. Let's figure this out really quick and then we can start refactoring. Because we want to be able to hand. All right, let's think of all the situations we have, and then maybe we start thinking of this. So we need to take an input, and we need to link it to a mixer, right? So in this sense, we're taking a source to sync, right? We need to be able to take a mixer and link it to an output, right? This is still source to sync, okay? What are some other situations that we have? Abex Caliber, thanks for the follow. Began, welcome, welcome, welcome. Thanks for the raid. McCann, Punchy, thanks so much for the subs. Giant raid. Giant raid. All right, so how many new folks do we have here? Do we need a brief intro of what we're working on? Skyrise, thanks for the follow. Abex, thanks for the bits, man. So I guess I can give a brief overview of what we're building. We'll just give a brief rundown in case there's some new folks here. Show you that big buck bunny. Skates08, thanks for the follow. Oh, he rated you as you ended? Okay, so here's what we're building. So we're trying to solve a problem both for a kind of a linear TV thing for Microsoft. Let's see, learn TV docs. So there's like this linear video feed here. So we're trying to solve that, and we're trying to solve a problem for GopherCon and other conferences, which is there's a lot of solutions for like broadcasting to some video streaming platform and then having it scale out really wide so you can have a lot of viewers. But the issue is there's not a lot of issues for like the production side of things, where how do you get multiple people on? How do I have Began on and then follow up his talk by somebody else's talk? So that's what we're trying to solve here. So we're building a video switcher that's going to run in the cloud that allows multiple people to stream OBS to RTMP endpoints. And then we can live switch between them and send them to one or more outputs. We can also retrieve videos from the cloud and play those. We can do picture-in-picture and things like that. So if this thing's still building, because I've been breaking lots of stuff, we can do a quick demo. Oh, Ash Fox rated you just before you left? Nice. Well, welcome everybody. So I can show off a little bit of what this thing does really quick. As soon as we compile. So one of the things that we're trying to work on right now is the introduction of WebRTC as both a way of previewing the inputs and pushing our output there. And we also would love to get like a browser to be able to be fed as an input into the mixer. So we're trying to, this creates a situation where now things can have multiple connections. So we're having to rethink kind of the architecture, the internal architecture. Come on, compile. I have seen OBS Ninja. So the idea would be that we could take something like OBS Ninja and have our mixer join the WebRTC connection and start using those as inputs. And we could like layer people in or switch between the individual participants and things like that. Why is this taking so long to compile? Okay, here we go. Oh, let's open up Postman. Okay, so if we come in here all over an HTTP API, we can submit, that's the output, here's a mixer. So we're gonna just submit some JSON that says, hey, we want a new mixer, we're naming it eric.dev, 30 frames per second, and here's our width and height. Boom. All right, so we're gonna use an auto output, which is gonna open a window here, but we can also send this to RTMP. So now we have this mixer kind of just playing a black video here. And then I'm gonna, oh, where's Big Buck Bunny? All right, let's get Big Buck Bunny first. Big Buck Bunny, where are you? Standard full HD, that's our MP4, okay. Okay, here's Big Buck Bunny, and we're gonna start playing this. And now we can see our video is kind of pushing here, right? But now what we can do is we can come in and we can update the input, and we're gonna change its dimensions to 768p. I'm gonna turn that down a little. We're going to add a little bit of alpha transparency, and we're going to change its position on the screen and make sure that it's all the way up. Oops. Big Buck Bunny. There we go. So now we've changed its size. We've moved it. Now we're going to come in here. We're going to add another input. And this is going to be the Sintel video. And this should come up behind it. And we should be able to see this bleed through. And we can come here and add an output.
I'm searching for someone.
I guess we'll take this one. Okay. So now we're going to add an RTMP output. And RTMP. And I know that the URL here is live stream key. Okay. Oops, we've already have one here named output, RTMP. Boom. And now this will take a second to start transmuxing here, but then we'll start seeing this. This is just an HLS video player that's reading in an HLS feed that's being transmuxed in Nginx as a preview. And there we go. There is now our output coming here locally as well as through RTMP. So that's sort of where we're at right now with all of these. I need to turn back on Dark Reader. Okay. But yeah, so we have kind of like a rough working proof of concept of some of these features. We still need to like productionalize it a little bit, make it more stable and better logging and containers and all of that stuff. But we're looking at WebRTC so that we can have like a production, like producer view, where the producer could be able to see the individual inputs and, you know, switch between them before adding them to the mixer or doing the picture-in-picture and things like that. And also being able to use it as an input from the browser. You should add, is it not part of project? All right, let's see. GitHub, yep. nvim config project. Oh yeah, you're right. It is not part of there. Okay. Okay, so there we go. Yeah, I don't know how we fix that either. I love when people use links like that. The GStreamer is composed of the API stored on the mixer. Is that correct? So GStreamer is the individual elements, but each one of the elements is managing its own, or each one of the types, the input, the output, and the mixer are sort of like managing their own GStreamer elements, right? So if we look inside of like the URI input, we can see it creating a bunch of GStreamer elements. It's responsible for creating like its own section of the pipeline. And then there's a link function that is currently called by the mixer, and the audio or this would be the audio mixer. This would be the video compositor being passed in. And it's basically saying, hey, input, link yourself to this. Oh yeah, URL shortener. I guess we could use like bit.ly or something, right? Oh wait. No, where's my share link? Where are you? I know we've got a link to this before. Reset, export, save as, save. Where is share? I'm losing my mind here. I know that there's a share. I know there is. Am I blind? Oh, here we go. It's the hidden link there. Okay. All right, bit.ly. Wait, is this not free anymore? Oh, wait, there we go. There we go. Code, eric.dev, config. All right. There we go. Fix. Okay. Is anybody here new to video? Like, what is RTMP? How does it work? What is, how do video streams work? How is video and audio encoded? Any of that stuff. I know we have a lot of new viewers here. I'm happy to do like a little... I've already got that kind of drawn out here, so I can do a quick like crash course on that if anybody is not familiar with it. I double click the video file icon and the stream begins in the player. I am practically an expert. It's like I'm a computer expert. I know exactly where the power button is most of the time. Except on weird laptops, and you're like, how do I turn this thing on? I want to know how it is compositing changes in real time. So that is actually a GStreamer. So GStreamer itself is a pipelining library. And so we can, let me run this really quick. We can actually look at localhost. Oops. I'm going to create a mixer really quick. So we can actually view a diagram of the pipeline. So GStreamer allows us to take these individual element types and chain them together. So as the notion of these elements here, and there's source elements and sync elements, and then the ones that both have source and sync pads are called filters. So they have the notion of a pad, and pads can be connected. And so each supports different capabilities, and they try to negotiate so that they can communicate in a shared format. So GStreamer just basically, it's a really cool way of being able to do video and audio stuff because you can conceptualize how all of this stuff works much better. So this whole project is just leveraging GStreamer under the hood, and we're chaining these elements together to get what we want, right? So T elements allow us to actually have multiple syncs on them, or multiple sources on them. So here, you can see there's nothing there. However, if I add an output and we refresh this, we can come find those T elements. Where are you? Okay, so here's the audio mixer. And here's the T. So now we can see here, this is connected here. Drysis, thanks for the follow. Leica the Human, thanks for the follow. So we can now see this split out. And same thing for the video. Here's the T, right? And if we added another one there, we would be able to, actually here, we'll do that. So if we back this up to create the auto type, right? And we refresh this, now you can actually see the T where it adds a second source pad. So what's happening, some of this stuff is the individual component types. So the audio mixer here is what's actually, it can have multiple syncs. So we can bring in multiple audio sources and we can set the volumes and things like that on them. And then there's this, back up here, there's this video compositor. And that's what is allowing us to put multiple videos and then tell it the Z order and their size and where they're located. And so you can actually do all of this from the command line. You can actually pipe these things together and build these giant strings of GStreamer pipelines completely from the command line. Code Ninja, thanks for the follow. Do people hate on GStreamer? Not that I know of. I mean, it's used by quite a few things. So, and these sync sources, filters, and such, are those more elements of a container? Right, so the pipeline itself is a container, or a bin as it's known. And we can actually wrap these things up in their own bins and connect the bins together. So up here you can see the pipeline. A pipeline is a bin, but we could also wrap these things in a bin. So yeah, GStreamer is ridiculously powerful, and there's bindings for a lot of languages. So we've sort of created our own types here, like inputs and outputs, but WebRTC is introducing some new things for us. The ability to have an input go to multiple places, as well as the notion of reusing one thing as both an input and an output. So now we're kind of like rethinking the design of the overall project and seeing what we need to refactor. I did some freelancing work for some video production companies that wrote their own systems like this, but never got to play with it. I always thought they were using FFmpeg. Yeah, I mean, lots of places use libav, which comes out of FFmpeg. Like OBS, that's what they're using. But there's a lot more places using GStreamer too. I went the route of GStreamer just because we're like magically connecting and disconnecting things, and I think it's much easier for me to kind of follow the flow of what's happening using GStreamer's pipeline system, right? It's really easy for me to follow the signal flow. I can look at the individual elements, right? And I can see, okay, well, this one's in a playing state. But occasionally the pipeline will be broken, and I can look and see that, oh, there's an equal sign here. Like this component's in a paused state. Why is it in a paused state? You can use libav from GStreamer. It's much harder to use GST from libav. Yeah, right, yeah. What's refreshing itself at 30 frames per second? Inside Sources, thanks for the follow. But yeah, prior to my job at Microsoft, I was at Comcast, and I didn't work as low level on video stuff. I did more infrastructure stuff and how to fail over video streams and stuff like that. So I got a little bit of a high level understanding of video working there, and now we're kind of diving down the stack a bit more. Ironically, everybody hated Comcast internet. The cable, actually, we had 5 nines uptime. So is everybody here familiar with kind of how RTMP works, how a video file is composed, how it ultimately ends up to the player in your browser? We can do a 2-minute crash course on that if anybody kind of wants to be brought up to speed. You'd like that? Okay, perfect. So apologies to everybody who's been around the 50 times I've done this before, but it's fascinating to learn. So, okay. So if we're talking about like OBS or whatever you're using, for Facebook or YouTube to stream live, all of them are streaming using a protocol called RTMP. So real-time messaging protocol. It actually came out of Flash, but this is just a transport medium. Okay. So what happens is OBS or whatever software is taking the individual video frames and audio, sampling it so many times per second, and that's kind of the raw feeds. So it's going to encode them using what's known as a codec, so it stands for code decode. So in this example, we're using H.264 codec on the video, and AAC and MP3 for the audio. So these are individual streams. These are multiplexed together and put into what's called a container. So containers have different formats. If you think about like a file extension for a video, MP4, FLV, AVI, right? All of those are container formats. They each support their own, not their own, but they each support different codecs. So that's kind of important to think about here. But they're all wrapped together in this container. Those bytes can be written to disk as a file, and there you go, right? So, or they can be sent over something, right? So these are being transported over RTMP. So RTMP gets to the Twitch side or YouTube side or whatever. This is basically how everybody does it. And then DevOpen, thanks for the follow. Then what happens is called transcoding, right? So transcoding basically means to change the codec of it, right? To re-encode it into some other format. If we just open the container and pulled out the individual streams and then stuffed them into a different container, that's what's called transmuxing. Okay? So transmuxing is really, really cheap. So what you were seeing play in that browser preview uses like a quarter of a CPU unit and I don't even know, like 60 megs of RAM or something. Very, very small. It's not a lot of work. So this is why, like, if you don't get a transcoder in Twitch, right, where it's only available in the normal resolution, because it didn't have to do any of the crazy CPU or GPU work to re-encode it. Okay. So what happens is, on the transcoder side, it's either transmuxed if you're not lucky enough to get a transcoder, or it's transcoded. And what that basically means is it's going to take it, it's going to rescale into a bunch of different resolutions, then it's going to re-encode them in a different format, but it's going to actually break it up into an MPEG transport stream container, and there's going to be 2-second segments, right? So each thing stored on disk is 2 seconds of video and audio in a variety of different resolutions. Then it's going to generate a manifest file that points to all of these things, and all of that is going to be pushed out onto the CDN. Okay, so RTMP is very, very low latency, but it doesn't scale very well because you essentially would need a server that sits in the middle that manages all of the client connections and forwards out all of the packets. So super expensive, whereas HTTP and CDN, really proven. So we take all of this, re-encode it into a bunch of resolutions, we break it up into 2-second segments, create an index file, what's known as a manifest, and we shove all of that out onto the CDN. Okay. So now from the player side, here's what happens. The player points to a manifest file, and we could look at the one for the very Twitch stream you're viewing right now. And it's going to start grabbing those segments and filling up a buffer with them. And that's all that's going to happen. And on this side, obviously, it's going to do the decoding, and it's going to send, you know, the video frames to your graphics card and the audio samples to your sound card. And there's a lot of timing that happens in here. That gets super complex, but we're gonna stick to high level. So what happens if you have a hiccup in your network connection, right? You have some sort of jitter or network issue, and you get a buffer underrun. It's not able to keep the buffer filled. The player is going to go back out to the manifest file and say, hey, do you have another resolution that's smaller? And then you're going to start pulling, say we watched this, you weren't able to keep up, and it pulls from here now. And it'll keep doing that until the network comes back, and then it'll go back. And this is how adaptive bitrate works. And so if you've ever noticed, like watching Netflix or Hulu or YouTube, your video get like slightly blurry, right? It's not as high definition for some matter of a few seconds, and then it comes back. That's exactly what happened. The player wasn't able to keep up. It went out to the manifest file, grabbed some lower resolutions of the next, series of segments until the network came back. Okay, I think I went over everything at a high level. If you have questions, I'm happy to answer them. Also, especially the first link here, if you want to kind of understand how video frames work and audio samples and all of those things and colors, formats, and things like that, that is a really, really good intro to it. In my Nginx RTMP, I have that set to 60. Is there any reason to keep that number low, the HLS segment size? So The HLS segment size is going to be based on the amount of latency that you're willing to have, right? So there's a minimum amount of latency to fill the buffer and things like that. There's also connection time, right? What happens when I try to start watching the stream partway through one of these segments, right? Is transmuxing just for compatibility? Yeah, right. So AAC and H.264 can be delivered over MPEG transport streams, which is what HLS and MPEG- use. So if we don't need to transcode it into different resolutions or transize it, then there's no reason to decode these individual streams. So I'm able to just pull them out and store them into MPEG transport streams. Thanks, that was super helpful. No problem at all. Smaller segments reduce the time for rebuffering, that adaptive approach. Right, yeah. Can a container contain multiple video streams too? I thought it was one video and audio per container. No, you can have, you could have multiple. There can also be closed captions in here. Right. Muson's correct. Yeah, it depends on the container. This would be a source to a sink. Well, I guess we could do this too, right? Link WebRTC. Oh, got it. Yeah, I use make MKV often, but I forget that MKV is a container. Right, yeah. Yeah, so MKV, well, yes, Matroska is a container, but it is also a encoding too, which makes things confusing too, right? Same thing with MP3, right? MP3 is both an audio codec and a container. Okay, so I think if we laid this out this way, then we basically create a situation where we're always telling the source to link the sink. Okay, so now we need to figure out how to unlink. Do we do the same thing? Melky, how's it going, man? Yeah, if you're not watching Melky, you definitely need to watch Melky. Also, if you are not watching Musin, you need to watch his stream too. He does a bunch of Rust streaming, way smarter than me. Big brain. You got more RAM? Did you download it? You see this, Melky? 128 gigs of RAM. I have this secret place I download my RAM from, and I'm not telling you. There's a thing called magic numbers, Stupak. Basically, there are a series of bytes at the beginning and often vary so often in a file. Wait, what was the question? How does one tell how is being used MKV? Right, so the individual files have headers. So the files themselves have headers. So we could actually do like a GST discover here, right? Pythonificated, thanks for the follow. Okay, so let me go back to this input, right? So we could just grab this WebM file, right? And we can do a GST discover on it. Actually, we're going to do it. So this goes out and fetches it over the internet, but it's able to look at the header and get some information from it, right? So this is just some tags and stuff like that. But here we go. Here's the container, and inside the container, we can see that we have a Vorbis audio channel. right? We can see the sample rate and some things like that about it. And then here we can see that this actually has 2 audio channels. And then here we can see that there's VP8 video inside of it as well. And we can get some information about its resolution and frame rate. All of this is like sort of just part of the header information. Yeah, Code Ninja, you got Coded Ninja. You got to get on that. You got to download the RAM. You just got to find your own site for it. The hardest part about downloading RAM is most people won't tell you where they get it. Okay, so I think that if we refactor to this approach, I think we create a situation where we're always telling a source to link. We're telling the source to link, and then we're handing it the sync to link to. And yeah, all of that is encoded in the headers, footers, which also tell it how many elements, pages, atoms, frames, whatever the format uses are in it, and how to advance to the next section, like an index, a book with chapters. Yeah, so and some of the stuff that's actually in the header is also like, I think frames per second is one of them. There's some things that are like calculated magically, like bitrate. Bitrate's one. It's basically calculated based on like the size of the file with the length of time the video is, which is actually not accurate because you don't know what the compression algorithm has done. So it's like a very crude estimate of what the actual bitrate is and things like that. So there's some of them that you actually need to get down into the stream and process that. Okay, so if we connect the source to the sync always, we have a sort of a consistent view, and we have solved for both of our WebRTC cases, right? Right, and then we could, in theory, take a mixer and link it to a WebRTC, right? And this would allow us to see the output of the mixer and send it back to somebody. But take the input dot link. No. And we could do a WebRTC, link it to the mixer, right? So this would allow us to take a WebRTC connection and feed that into the mixer as an input, but then send back the final produced thing as our video stream to whatever session that we're on. Okay. Robin Gare, thanks for the follow. So I think that this is probably the best way to do this. That works for all of these scenarios. So now that works. We just need to now abstract everything so that Mixer doesn't contain these things. And then the other thing we need to do now is figure out how we're going to have a source. I'm going to get rid of all of this. So now it's always an input, right? So does this have its outputs on there? Is that what we're going to manage? Well, Musin, you're going to have to probably give me some tips here, because I think that in this case, if we had like some sort of vec of outputs here, we do come up with a situation here where both the input and the application own the output. So I think we're going to end up having to wrap them in an arc mutex, right? It would look something like this, right? Like obviously we're like pseudo coding right now, but it would look okay. So I think we would have to have something like this, and we would obviously have inputs, mixers, whatever. Oh yeah, Usenets are the best place to get RAM. I mean, it takes some time, and sometimes you have to pull the individual bytes from different places. But I've heard you can get some good RAM on Usenet. Is it even a live Rust stream without Musin helping make better code? I'm telling you, I have all of my Rust knowledge. I have Musin and Mr. Halsey to thank for. There are definitely some things that I've run into, or the error messages here, especially with like using like the really macro heavy stuff like warp and Tokyo and things like that, where I would have just given up on what the error messages really meant. All right, I'm gonna take that web. Oh no, because that's pretty embedded in there. Maybe what I need to do is stash WebRTC. There is so much stuff here. All right, what is all this complaining about? WebRTC on. Oh, no, it's not in Git yet. So tab, new, source input, WebRTC. I'm gonna get all of this to go away for right now. What is all this on one? Okay, so here we're just gonna do this. There we go. Or maybe not. What is this complaining about? Not found in scope. You know what? Okay. Where's WS Connect? Nope. Oh, we weren't even calling it from anywhere. Okay. And these are just I try to keep the warnings as cleaned up as I can, just because it starts getting really confusing to find my actual error messages when I have too many of them. Okay. So we just have. Oh, I missed one. Okay, that's all gone. So this is sort of what we're thinking. So do outputs know anything about what they're linked to? Hey, no Slack sounds. I didn't even realize that I have notifications on here. It's people messaging me about GopherCon stuff. Okay, so I'm just now thinking about this. This is not going to work because we don't really know what the elements are, right? Does it need to work the other way around? PTSD. It's like, no, I can hear all of the messages and email notifications. All right, where are my sounds? Notifications. None. No sound. There we go. Do I use Arch for InfoSec tools? Wait, Audible, Slack, and Discord notifications are so disorienting not coming from your computer. Yeah, I don't. I turn off all sound notifications. I don't care for sound notifications, period. I do use Arch for InfoSec tools. I mean, I haven't been able to do InfoSec stuff in a little bit, but yeah, I've used Black Arch and Arch Strike before. Arch Strike is pretty cool because it allows you to just have a different package repository that you can fetch your InfoSec tools from, rather than having like a whole other distro. Yeah, I have 3 computers as well, so I'm like, did I not have it open? He has a pigeon sound for his stream alerts, and I honestly have to think I have a pigeon in. Oh, that's funny. That's funny. Okay. Okay, so this isn't going to work because each one of these elements encapsulates their own section of the pipeline. So would it still look like this though? It would be mixer.link input, right? It's effectively that way, right? Because the mixer... Well, no, because we would be passing in some stuff, right? So we would, I guess, ask the mixer for its audio and its pipeline. How is this going to look? Because that's what we need on this side of things to connect ourselves. Oh, can you add the repo to Pacman now for Black Arch? I believe you couldn't before. Oh, awesome. Awesome. I think that they have a bigger maintainer team too, so then that would probably be my preference. Okay, so it's funny. I don't know how long I've been on stream for an hour and a half. We haven't even really coded yet. Some of these things are like complex to try to figure out how to design around. I can't remember if I thanked you. Rabin Gear, thanks for the follow. Okay, so here the mixer would hand its information. But I almost feel like I like the idea of this. And then maybe the input asks the mixer for its audio and video sources. Right? Like maybe it ultimately calls mixer.audio sync. Right? And then this could be part of an interface. So with Rust, you have to seriously consider ownership, lifetime mutability. Yeah, I do find with Rust, I have to like stop and back up. If I don't, then I end up like refactoring and doing the same thing like 15 times. And then sometimes I feel like I'm just scrambling. Okay, so in this case, we could have the application and the input own where it's going. I think that we're going to end up in a situation, though, where what we really want is a vector of traits, and that has been really painful for me in the past. Because it'd almost be like it'd be nice to have an interface here. Right? Outputs would have these methods on them. Inputs would have, source elements on there. And then we could ask it for it, and these would return back a GST element, right? I tried that before, and that's how I ended up with this enum approach, where so this could work, right? Okay, so this is sort of what I'm thinking. A box.dyn foo read write, but single owner. I want to say the box.dyn foo was how I was doing it before. And dyn foo read only, borrowed, and mute dyn. Okay, so because I mean, in theory, this could be a sync trait, right? And this could be a source trait, right? And then WebRTC could be both, right? I still wonder whether this is the correct direction that we want this to flow, though. Because right now we have this, right? Where we tell Mixer... no, so... Actually, no. This is how it works now. Except Mixer is just passing us its individual things. I think in this order, right? So this is how it's currently working. But output is the same. Output's the same. Okay. Right now, I would give anything for a basic HTTP API project. Okay. So this is how it works now. So it's not much of a shift. The main shift would be, do we want to pass in each of these elements individually, or do we want to pass them in as some sort of trait or something where they're going to adhere to an interface and then it asks it for those elements? We could also ask it for pads, like request pads from it. And so I guess we should really think about what does it look like for... I'm going to move this down because this is a new thought. We didn't consider what does it look like for... What does it look like when we unlink? So who do we ask to unlink? I mean, I guess this would make the most logical sense, handing it the mixer and telling it to unlink itself. Who holds all of the connections? So here, I guess we would still ask for the pipeline, which would be okay. I feel like we need to manage the pads. Yeah, so cell and ref cell are super new to me too. I really need to learn more about those. So this is how it works now. Which is fine for one individual thing, but when we have multiple, this is the element, and what we really want is a pad. All right, so let's, I'm going to close out some of these. Let's just poke around the code a little bit. This is mixer mod. Okay, perfect. This is, we're going to look at this first. Okay, so here's where we're doing the link. But at this point, this is just an element. I kind of feel like we need a pad here. We need to manage the pads. Because the pad is what we want to hand back. When we unlink, we want to tell it specifically which pads are they. Well, let me pull up URI really quick. So here in our unlink function, that's doing something like mutex guard implement deref mark. Whoa. I don't even think I fully understand what that line of code does that you just said, Musin. Okay, so here... Okay, yeah. So here's our issue. Well, we do have an audio T, which is connected to the source. Audio Q. Oh, so we're splitting this entire thing wrong. Because what we ultimately need now is we need like a T here, right? Because we need it after it's gone through all of this, and then that's when we need to send it somewhere. So how's that T being used now? All right, we need to find where it's linked. Okay, so in this case, we are taking... Oh, right. So this is where we're splitting it if we want it recorded. Which is sort of like a unique use case, but... I'm almost tempted to like create a new directory to just like experiment with this, because we've got so much kind of code in here that it's going to get really kind of confusing to rethink all of this, and we're going to break so much stuff while we do it. Because we're going to need to remove probably all of the record logic to begin with, because that's not going to be the way we're going to implement it anymore. The mixer is acting like a docking station at this point. Does it consider itself a trafficker or exchanging passengers one for one, like receive for send? I'm not sure what you mean, Punchy. Right now, Mixer just sort of owns it has its own section of the pipeline, but our type owns the inputs and outputs. So, like the first thing that I think we want to do is actually extract that out. I think that we want our application to own Mixer's inputs outputs. I don't think that we want them inside here. I'm trying to think of how to do this because I think like we're going to be getting a lot of stuff here. A lot of stuff. Right? Because what do we have? All right, so we have the HTTP input mixers. We don't really have an application. What do we want to call that? I guess a switcher, right? So we can have like a parent type that's a switcher. Like kind of at this level. And then that would own everything. So like type struct switcher, right? And this would sort of own mixers, inputs, outputs, right? So maybe that's the first refactor that we need to do. Which is going to be a big refactor. Because everything inside the mixer depends on this relationship. Everything on the HTTP logic requires this. I don't know. All right, thoughts, everybody. Should we try to refactor this in place in stages? Or should we just start kind of like a new project where we can pull all this stuff in as we need it? Because I think there's a lot of coupling here and there's a lot of things that are going to break. And I almost feel like we need to build like maybe like a sample, very minimal pipeline where we test like maybe like test sources and maybe like the auto output. You can set up a workspace or just use a path or git include if you want to reuse types. Yeah, the Moonlander I am so excited for. I cannot wait for that to get here. Okay, I'm thinking that I might just move into another directory here. Okay, I'm going to save that as an example. Okay. I just want to experiment really quick with just the relationships between things. So, I don't know. Cargo. Nope. Cargo new bin. And then we'll call it, I don't know. Temp. Okay. What am I? There we go. Oh, gotcha. Yeah, yeah. Okay. So this is just a starting point. So I just want to experiment with these relationships and make sure that they're going to work. So if we have a type here, type struct app. I don't know. Okay, so there's our app. We have type struct input. Okay. Output mixer. Okay. That Rust looks very Gopher-like. What do you mean? Oh. Ah. The problem with using multiple languages. I didn't even catch it. Didn't even catch it. All right, so we're just going to use that for now. I just want to try out a few things here. So we would manage inputs, vec, input, right? So we're just trying to come up with like a minimal example here just to validate assumptions. So, because I think right now with all of our GStreamer elements and all of that, we're just making things really, really confusing. So use, I always forget standard collections. I thought it was in here. Rust vector. Oh, it's in the prelude. What's my error? Oh, I'm assuming it's that, and it's just missing commas, right? Yeah. Okay. Okay, so we have this relationship. However, we have a situation where we might, what were our examples we want to try out? So let's just do a I almost did this too. It's like I really want to write Go today or something. Okay. I guess we're gonna have to create an app first. So let app equal app inputs vec. All right. Is it? I can do that to get an empty vector, right? Or do I have to do a vec new? Okay, yeah. Oh, they all work? Okay, so so now we want a situation where we would do something like we want to create an input, right? So let I equal input. Oh. Okay. Okay. So far we don't have any issues because everything is owned here. However, if I were to, what were some of our examples here? Let me go back into switcher, temp. Okay. So we have sort of these things, right? So I want to take my input now, and I want to link it to my mixer, right? Oh, so we're going to need to use a trait here. So okay, so we're starting to figure that out already. So implement input, and we get a link function. Now I have to look up trait implementations, because basically that's what we're going to want to do, right? Is pass in, I don't know, sync. And this would be something that implements sync. Is that right? Okay. LRD, thanks so much for the follow. Okay, so I'm just going to move this up top here. So trait, sync. A few versions ago, there was an actual difference between vecnew and vecnew is a const function, but vec would do. Okay, see, here's sort of like where I'm going with Rust. So every time I'm like, okay, and I'm starting to get a handle of it, then somebody posts something like this, and I'm like, what the hell is that? Okay, so this looks like it's a generic type over a slice of, I don't know, that's like a blank identifier. And then we're calling a static method on it, which is called into vec, and then passing it. Like, what is all of this? Okay, so here we would need to do something like this, right? So I'm not going to return back a result type, but here we would say implement sync for no, we want the other way around. So this is link, but we need implement sync for mixer, right? Basically, would allocate an empty slice directly into the vec. Oh, wait. Oh, it's compiler only. So is that syntax the equivalent of doing like a box new? Is that what that's doing? Sort of box new allocations on the stack and then moves to the heap. So what's the original syntax? Is that stack? Box is a placement new C++ terms will directly allocate on the heap and not have to do the move. Interesting. Yeah, so the thing that I find once you get past like the basic usage of Rust is it really requires kind of understanding what the compiler is doing for you. I mean, at least that's my current view of it, is there's like a giant leaky abstraction of needing to understand what the compiler is doing. Which is good, right? Like don't get me wrong. VGang, thanks for the follow. Because Rust is serving the use case where you're trying to design software where you want control over, is this going on the heap? Is it going on the stack? How long does it live for? But from an adoption perspective, it takes a lot of time to build up all of that knowledge of what the differences between these things are. Oh yeah, yeah. Don't get me wrong. I think that C++ is even more confusing. So, and like I said, it's not necessarily a bad thing, right? The thing that I enjoy about Rust is the amount of control that I get over those things, right? Where I don't have the runtime and I'm making these decisions. It just takes time to build those up and kind of get them, you know, committed to memory. This is an associated function, not a method. Oh, duh. Because we need to pass and self, right? Not found in this scope. Oh, right, because we're linking M. You know, I'm going to do this. That's going to get really confusing. Input, input, output, mixer, input. Okay. Normal users will almost never see box. Okay. I always find it nice and helpful to understand internals, but I do not think it's necessary to use Rust. Yeah, some of the basic stuff with Rust, right? Like I'm flying through some basic stuff with Rust. Okay, so here we go. So now we have this trait, but what happens when the input needs to store its, like, I don't know, what do we want to call it? Outputs? Outputs. So here is where we would also have a link to these things, right? So what happens when we want to store this here? Self dot outputs dot push here, right? So the first issue we're going to get is the fact that this isn't mutable, right? Placement is new in C++ is basically skip the memory allocation because we've already taken care of that. It's on the heap or pre-allocated and just call the constructor. Rust also had a operator one time for placement new. Yes. So the thing with Rust is I think that if I came from a C or C++ background, I think that it would make a lot more sense to me. Okay. So here we need to supply outputs, and this is going to be a vec. All right, so here's where we get into implementing a trait. So expected struct output found type parameter implement sync. Line 9. Oh, right. Okay, so here's where we need to do the box, right? So this would be a box dyn sync, I think. No. Oh, right. We need to do a box new around us. But box new sync. I know that there was an issue with using box that I had before. Help consider adding explicit lifetime bound and put. Uh-oh. Here's where I just do what the compiler tells me to do because I don't fully understand it. Box requires the T to be static, while implement sync could have any lifetime. Okay. All right, so we cannot borrow that as mutable. That's pretty easy. Okay. So that's not bad. Right, then we're managing everything up here at the app. The app would have all of the methods for adding inputs, adding outputs. And then I guess we would want to link things together. What other situations do we need to consider here? I mean, we still need the unlink too, right? Well, how does this work then? Because did we transfer ownership here of this output? Yeah, because we never pushed this output into the app either, right? So we need to do that. Dot put or app dot inputs dot push input, right? Yeah. So here's our issue. So we need to do reference counting, right? Priven, how's it going? Static here just means owned and not borrowed. Okay. I guess that would make sense. And static T and T static are the thing people run into, get confused about. When you pass it to the function, you'll have to move it. Are there good places to look up what kind of control is possible in Rust that separates from the implementation details? Wait, are there good places to look up what kind of control is possible in Rust that's separate from implementation details and mutebox RC? Christoph, thanks for the raid. How was the stream? What were you working on? Great, coding some Python and listening to Coldplay. How about you? Not bad. We wanted to add a feature, and that turned into a situation where now we need to like refactor the entire code base to support it. That input is being moved where you're pushing it. You cannot use it after. Right? Yeah. And static T is a lifetime that outlives all current lifetimes, while T static means the type isn't borrowed. Okay. Yeah. So we're gonna end up now. This needs to probably be replaced, right? Where this really needs to be arc mutex, right? I just feel like that's a lot, right? And maybe this is why I did it before. I can't remember if I thanked you, but thank you for the follow, V-Gang. So would this also be an arc mutex dyne sync? Is that really what that would look like? That doesn't seem right. Oh, yeah. So here we need to use standard sync arc and mutex, right? Okay, so that would work as a box. Okay. So this would be arc new mutex new. Well, really, this would be different, right? I really don't do this. It would really be up here, right? This would need to be an arc mutex. Right? Because something else already created it. It's just passing it into me. Saw you sitting and thinking thoughts. What was everybody working on over in Christoph's channel? Okay, so what are we doing? What are we doing? So this, oh wait, we still have an error. Expected struct sync found struct input. Oh, right. Okay, so here we need to do arc. I guess we'll just do it here. Arc, new, mutex, new. Okay. Method not found in. Because we need to do a dot lock dot link, right? What am I missing? So because I need to do a clone first? Poison error. Wait, no method link found for enum standard result. Oh crap, right. So this, I mean, we don't want this here, but I always forget you need to unwrap the lock. Okay, so expected struct sync arc found mixer. Okay, so we need to take our mixer, we need to wrap that in an arc new, mutex, new. Okay. You hate Rust? All right, so value borrowed after here after move. All right, because we need to clone this, right? Okay, and then app needs to be mutable. Okay. Waffle Ethics, thanks for the follow. Okay. So we're just sort of exploring kind of what a new API might look like for this. Okay, so this seems like it would work, right? So now our app both owns something and our input has a reference to the things it's connected to. Okay, so now our issue, I think from like a bigger architectural standpoint, this should work, right? But now we have a situation where we need to figure out exactly how our link and unlink functions are going to work. So I'm just thinking here. Zig. I haven't done a whole lot. I really wish I knew how to design things. You're talking about like application architecture? And some of it's just sort of like thinking out what the exposed API will look like, you know, and then with Rust combining that with how ownership is going to affect things. So okay, so this I think as far as like ownership and everything is a solved problem. We could refactor everything to look like this, and I think that we would be okay. So now the next phase is how do we figure out how we're actually keeping track of the elements, right? And I think that's the more challenging part. So one thing that we could do probably is if we go back into our switcher here, nvim source mixer mod. All right, so if we take a look at this file and we go to the link method here, I mean, this works too. When we're calling link, we're passing in our pipeline, and we're also passing in the mixers themselves. However, mixer dot, if we grab like video mix, where's my completion? Is like Rust Analyzer just not caught up yet? What's going on here? There we go. Okay, so mixer, video mixer, right? We'll clone it. So we do have the ability here to get request pad. So we have the ability to ask the mixers T, right? So this is really the T element, I think. But we have the ability to ask it for its pads. So we could have link actually take in pads. And we could manage those. I want to make a simulation library using async await, and I just locked myself. Yeah, I spent several hours yesterday refactoring this project like a bunch of times trying to figure out how to lay things out. That's why I think I'm kind of like in this really basic primitive example of things to figure out everything before I go and refactor all of my code to fit it. So then I guess the question is here, all right, let's talk this out. Okay, so at this point we create an input. The input's just hanging out there, right? We create a mixer. Okay, so now maybe this should work the other way around. Right? Maybe it's the mixer that we want to link to the input, right? And then the mixer would be able to ask the input for its source audio. Audio source, right? And its video source. And then those would be able to create the pads that they need, right? And then maybe it's not a link method, right? Maybe there's a function on the mixer that we call that says it to link it to the input. Mixer link, I guess it would be link, right? this is not valid Rust, but we're just sort of talking this out. To test, thanks for the follow. So the link function could look something like that, right? Where it's requesting these things, and then maybe it manages those things. All right, so let's think about this for a second. So maybe this is actually on the mixer. All right. You go away for right now. Okay. All right, so all right, so I'm kind of thinking here, what if this was like syncs, right? Add sync. I don't know. Because a mixer could be link sync. Right? Okay, so this actually, so this might work, right? So then if the sync here had function, obviously we would need our sync pads, right? So we would need audio sync pad. And video sync pad, right? So the individual types could probably track these, right? Like audio sync pad, right? It could have that internally, which would just be like a GST element, right? And so if we had these, then we would be able to, I guess, also do, maybe wrap them in an option, right? And if they exist, we hand you back the one that's already there. Crap. No, we can't do that. Because this creates the same situation that we have now, which is you only have one. Concepts are where you limit your templates, right? All right, I'm starting to lose myself here. Okay, so in all of this, we have some working code where we can have multiple ownership here, but we still don't have the individual pads, right? Because output here could be connected to many things. We don't know which one of those things are us. Okay, so separate thought here. I'm just gonna move that out of the way. So a separate thought here is, what if we had a struct link? And audio element, right? And a video element and a pipeline. So what if we had something like this? I guess I should bring this back. And then when you called link, what if we created the link type, right? So we request pads, create link, and store pads on it. Then we returned back the link. Okay. So now internally we could have a reference of syncs that we are linked to, right? I guess at that point I don't really care about. At this point I wouldn't really care about the elements themselves, right? I would expect you to manage them yourself. I'm just responsible for making sure data flows to them or data from them flows to me. Okay. Okay, yeah, I mean, so that may work. Sahel Dange, thanks so much for the follow. So, all right, maybe I should make sure that this compiles first. But so this is my rough working theory now, is that we just have a type. Whoa, did I caps lock? I hate when I do that. Okay, so we just have this link type, which is not going to compile right now. But the link type holds pads. No, we want pads here. So this is going to be on our side. Wait, whose pads are these? Whose pads? I think I just figured out how I'm going to do a project I wanted to work on, making an open source video or Ustream live. Oh, nice. You're going to build one? Are you going to use GStreamer? Are you using GStreamer? Okay. I'm going to just create a type here, struct pad. This is just going to serve as our placeholder for what will be a pad later, right? We'll do the same thing for pipeline. I just want to make sure that this is going to compile and work the way we want it to. Okay. Okay. Awesome. I'm just happy I have like introduced GStreamer to other people. Okay. Oh, I gotcha. Yeah. If I still wanted that GST thing to work. Yeah, and right now it's okay if it doesn't, it's not perfect. I just sort of want to, I'm just sort of like building like a minimal proof of concept of kind of the flow of things because we have so many things implemented already in the actual project. There's going to be a crap ton of compiler errors when I start doing this, and I almost have to like go all the way down through the refactor just to find out that it's not going to work. So that's sort of why I'm just have like this minimal proof of concept here to see how that's going to work. Okay, so on my input, I guess I could have syncs here, right? But really, I don't need this, right? Because it's just going to be a link at this point, right? Right? Okay, so let's follow this through. All right, so we create an input. I guess we don't need anything to, we don't need the arc mutex around it anymore, do we? Hold on. Just a neat pattern of using unit to get things going. Yeah, no, that is actually really cool. Okay, so. I mean, do we need to manage the name? Right? Alright, you go away for now. Okay. So we create an input. I don't think we need it in an arc mutex anymore, because we shouldn't have more than one thing owning it, right? It should be able to just borrow it. Okay. I'm not sure if you're aware of the interior mutability pattern, but it is a good thing to be aware of. I don't think I am aware of that. Oh, oops. These should be Vec. I got a little carried away. My bad. Okay. So links. Wait. So we do have a situation where I think the link needs to have that. Okay. Instead of arc mutex foo, you do foo arc mutex ... and then foo only has self receivers internally. Right. Okay, I'm going to copy in this and see what you're talking about. LeQuinn, thanks so much for the follow. Okay. So let's check out what Musen had to say. All right. We're going to split this up into multiple lines. Okay, so you're saying instead of an arc mutex foo, we do what? Struct foo arc mutex. Wait. Is this just your own placeholder, or is that actually something that's Rust specific? Dembski, how's it going? The arc just gives you multiple ownership. It was my shorthand. So but this would be some property on the type, right? This would be bar arc, right? Or are you saying something different? There we go. Example code. All right, sometimes a type needs to be mutated while having multiple aliases. In Rust, this is achieved using a pattern called interior mutability. A type has interior mutability if its internal state can be changed through a shared reference to it. This goes against the usual requirement that the value pointed to by a shared reference is not mutated. All right, so unsafe cell type is the only allowed way in Rust to disable this requirement. When unsafe cell is immutably aliased, it is still safe to mutate or obtain a mutable reference to the T it contains. As with all other types, it is undefined behavior to have multiple mutable unsafe cell T aliases. Other types with interior mutability can be created by using unsafe cell T as a field. The standard library provides a variety of types that provide safe interior mutability APIs. For example, refcell, let's look at that, uses runtime borrow checking to ensure the usual rules around multiple references. Standard sync atomic module contains types that rep a value. Okay. Idiot moron, thanks for the follow. So this is subtyping. Variants. Ah! You linked it. Oh no, it was Vega. Okay, so this is just the docs for it. I want to see like some example code for this. Is there like a Rust by example for interior mutability? Rust by example interior mutability. I think that's what we were just looking at, right? The Rust reference. Okay, this is from the book. All right. Okay, unlike RC, the ref cell type represents single ownership over the data it holds. So it makes ref cell T different from a type like box T. Recall the borrowing rules you learned in chapter 4. At any given time, you can have either, but not both of, one mutable reference or any number of immutable references. References must be always valid. With references in box T, the borrowing rules invariants are enforced at compile time. With ref cell T, these invariants are enforced at runtime. With references, if you break these rules, you'll get a compiler error. With ref cell T, if you break these rules, your program will panic and exit. Oh. See the quote of the week section. Quote of the week. Okay. When the answer to your question contains the word variance, you're probably going to have a bad time. Okay. Okay, interior mutability, a mutable borrow to an immutable value. Okay, that makes sense. All right, you get the following error. Cannot borrow X as mutable as it is not declared as mutable. Right. Okay. However, there are situations in which it would be useful for a value to mutate itself in its methods but appear immutable to other code. Code outside the value's methods would not be able to mutate the value. Oh, right. So yes, this is something I do want to do. Okay, let's see. All right, so we have struct A, and we have a mutex over wrapping A. Okay. We're dereffing self. I believe that's what that does. This logic like throws me off sometimes, because like this ampersand and this star don't do what they do in other languages. Codephobia, thanks so much for the raid. You're dereffing the mutex guard. Oh, gotcha. Right. Okay. Yeah, because this is actually returning a mutex guard. And you can't do these operations on it, right? Now, if I'm understanding this correctly, Musin, right? Like if you did do, I don't know, let's call it let b equals self dot a dot lock dot unwrap. Here you could do b plus equals 1, right? Is that right? That's the point of this deref here, is to avoid having to do this binding. What were you working on, Codephobia? Need to tell it which deref to use. Either and guard to get and t or and mutex. Oh, you're working on your Twitch bot. Cool, cool. I need to do some more work on my Twitch bot. Okay, so let's get to what this is doing. Okay, so get is taking a borrowed self and it is returning back a mutex guard. I guess this represents some sort of static lifetime in an I32. Even then you can't and mute a plus 1. It has to be and not mute. Yeah, see, all of this stuff is what like really gets me confused. And I don't think a lot of this is really talked about in the Rust book either. It's an elided lifetime of the mutex. Joy. Okay, so here we're calling a foo, right? Oh, right. Yeah, because here we don't actually have a mutable a, right? But foo internally mutates a. Yes. Okay, so yes. Let's just we'll do some Rust learning today, because this is something that I think I have come across quite a bit in building stuff in Rust that I want, where I'm just trying to call into some type, and I don't really need a mutable version out here. It just needs to mutate itself. Okay, so let's try to understand this a little bit better. So does this work because self owns it? I guess I'm trying to understand, because nowhere in here is it a mutable reference, right? Self comes in as a receiver, but it's not mutable. So how does that work? I know we have some examples here, so let's see what we can get working. Mutex guard derefs into an amute t or nan t via deref or deref mute. So this is what turns it into a mutable t. All right, let's refactor one of ours and see if we can kind of understand what happens here. The only way it works is because it uses unsafe cell internally, which is blessed by the compiler and can get around the mutable requirements. Okay, so let's use one of these as an example. So this link sync here, right? You're saying that we don't need this. If we wrapped the vector in a mutex, wait, which type was that in? That's in input. So in input, we would wrap this in a mutex. New. Okay. Okay. Oops. Okay. If you're calling mute function, it'll try to deref mute otherwise. Gotcha. So it's basically deciding what it needs based on context. Plimplims, thanks so much for the follow. Okay. Method not found in input. Wait, what? Okay, so in this particular case, right, so for input, we wouldn't necessarily need to make this immutable. Or mutable. Wait, why was I making that mutable to begin with? Oh, because down here I was calling that, right, okay. So app inputs push. Oh, we were doing it on app too. Okay, let's start with app. Well, we'll leave that alone. So for... Oh, that's fine. Input... How good does my game need to be to get recognition from Facebook or Google? I have no idea. I'm not in the game development industry, so I'm really not sure how you get exposure like that. That is a very, very good question. Okay. So I've lost myself again. Okay, so let's get this compiling again really quick, and then we'll figure stuff out. Online 50. Oh, right. Syncs. Okay. And then mixer, is that because that needs to contain syncs as well? Okay. Okay. Expected struct standard vec found struct standard mute deck. Oh. All right, let's get a basic example, and then we'll try and convert to the interior mutability. Okay, self is a reference to the data it refers to cannot be borrowed as mutable. Okay, so where is this? Line 30. Okay, so here is where we've got the interior mutability. Okay. All right, so here's where we have our situation where we're trying to do the interior mutability, right? So here's our prime use case. We have, this is on line 31, right? So this is inside the mixer. Okay. So here we have a mixer. We've created a mixer, but we don't need a mutable reference to it out here. We just want to be able to call a method on it and have that be able to mutate itself. So if I understand this correctly, what we want to do is wrap this in a mutex. And then here we would do a deref on a syncs.lock.unwrap. Am I missing something here? Oh, first we need to fix this, right? Mutex, new. Okay. So unit struct cannot be dereferenced. Why? And why are you a unit struct? Am I missing something here? I don't need the deref there. Okay, so here, okay, sort of lost where we were going with this. So now I'm trying to remember I kind of lost my train of thought here, how we were going to do this. So that's linked sync. So many screens and LEDs. Are you able to see all the screens, or you just mean these individual windows? You can also control the stuff too. Oh. I don't know what's going on with my bot lately. Hold on. Okay. There we go. So you can change all this stuff. You can do whatever you want. Wait, why does the second one not work? Interesting. We need to do some debugging on this. Like lately something happened. Well, nope, no, there it is. I guess maybe it's Twitch's chat API slow or something. And you can also do, you know, hue purple desk, right? And hue blue electronics. Oh, I guess we gotta wait for the party to be over. Yeah, there's just a delay, which is really, really weird. But yeah, so you can control all the other lights, right? So you could do green, I don't know, pink, ceiling, oops, hue, pink, ceiling, hue, green, or I don't know, blue, desk, hue, purple, electronics. There we go. So even talking about what? Oh, the light show? Yeah, yeah. Somebody was commenting about the lights. So, you know, I forget that. Rajita, thanks so much for the follow. I forget that, you know, viewers change organically over time. So, you know, a lot of the people who were here when we built all of this on stream may not be here and using all of this stuff. You know, there's also all kinds of funny sounds, I think, if my bot is running. Interesting. Why is that not connecting? Localhost 8080. Is something else running on port 8080? Tamara, thanks for the follow. Okay, so we clearly have something else running on that port. Wait. Okay, hold on. Let's figure this out. We're gonna fix the bot because that's gonna drive me nuts. Okay. Do I have what port it's gonna run on? That's just there. Car or EricBot dev run help. I don't have an option for what port it runs on. All right, hold on, let's kill this. Yeah, there's something running on 8080. What is running on 8080? LSOF, SI. Yeah, but we see OBS and we see Microsoft Edge. Cat to Beast and Dana Voice, thanks so much for the follows. Okay, so I want to know what this is. This resource or route could not be found. What are you talking about? What are you talking about? I don't know. I'll figure this out. Maybe what we should do is, oops. I'm just going to, where's 8080 in here? All right. We're going to change this to 8081 for right now. I don't know what is currently running on 8080, but this is an easy enough fix. Go build. And then I'll change OBS to point to 8081. All right. There we go. Okay. All right now. Now we can do sound spaghetti.
Would you like me to look up a recipe for a light bolognese sauce? It should pair quite nicely with your spaghetti code.
Yeah, so I have connected not only like my LEDs with Twitch, the key lights that are like on me, right? Those are controllable. You can do strobe. I have also connected OBS, so you can change the scene on me. I have some plans to Primogen. If you don't watch Prime, you should definitely be watching Prime. Has done some stuff to control Vim through his thing. I want to be able to do that as well as like maybe control i3 and stuff like that. So I'll get to that eventually too. ASDF win. So I'm not Dvorak yet. When I get my new keyboard, I'm actually half tempted to switch to Dvorak as well. And before Twitch codes Rust. You want access to the printer? This is running on my Linux setup. On the Windows setup, I actually had VST plugins running and allowed people to control OBS by sending commands in chat that would apply filters to my voice. Let's see. Twitch. Let's quickly mute this. All right, it's already muted. Am I going to be able to get to my videos here? No, because I'm live, right? Is it /videos? /videos? Aha. Fab, thanks for the follow. Hello, Eric. What is the best Linux distro for web development? Thank you. That would really depend on your familiarity with Linux. How familiar are you with Linux on the desktop? So let's see. All. Okay. Here we go. So this is like when I implemented it. I have one more go with it before I do that. So hit me. Oh. So this is everybody. I decided to read a wiki page and let everybody just go nuts with the control.
Visual Studio Technology. VST is an
audio plugin software interface that integrates software synthesizers and effects units into digital.
VST and similar technologies use digital.
So that was a fun night. I've used only with Ubuntu, but is there a better distro? I mean, Ubuntu most people use, right? So it's a good starting point. You know, if you get into things like using like I do Arch and things like that, you're going to end up spending a lot of time configuring and fixing things, right? So like right now, NVENC isn't working because I updated my kernel and NVIDIA drivers, and now OBS doesn't like my hardware encoder. Oh, yeah, that would work too. As far as like the drop down. Yeah, they all give you different package management. You know, like Arch is basically like bare minimum, and then you decide how you layer everything together. But it does create situations where you have to highly configure how these things are going to work together and things like that. So I have not personally used Manjaro. Yeah, Ubuntu is going to be one of the, you know, works out of the box distros. You know, and package availability, right? So so things like, you know, Spotify or something, right? If you want to use applications written by places, Ubuntu or Debian based distros and Red Hat based distros with Deb and RPM packages are going to be the easiest to find software for. If you're, you know, trying to download Dropbox or Spotify or something, they're going to be available in those packages. If not, you end up in situations like I do, where I have, you know, I'm trying to run Teams and Edge, and they're giving them to me in Debian, and then I have to like use like things like DebTap to like convert those Debian files into ZST files so that I can get Pacman to install them and things like that. Sounds like it's raining. Okay, so here we were able to get our interior mutability, right? So that's good. But we still need to figure out this kind of link situation. So in this case, let's just say we're gonna just return back a link. I guess it would probably need to be an arc mute. No, well, because we could have a cloned copy of this, right? Because inside of it, these things are all clonable. So the only thing that would be copied is the name. I think that's fine. So let's just say, in theory, we return back a link from link sync. So the mixer. Wait, let's change this. Sources. Sources. Because that's the one we were doing first. So sources. Crap. Okay, we'll go with sync first. Delete that. Syncs. Okay. Is that no? All right, so this is a point we need to think about. Yeah, yeah. They're all going to, you know, work the same, right? They, at the end of the day, they are all the Linux kernel, right? So the difference really is all of the other things, right? So that's all they are, is they're a distribution. It's like, you know, if you go to the store and you buy a new laptop, right? I mean, you have Mac versus Windows, but let's just assume you're in the market for a Windows computer, and you go to the store. They are all computers running Windows that you're looking at, but as far as what's on them, HP's going to install some stuff. You know, Dell's going to install some of their own stuff. So it's sort of like what's packaged with it. So that's really what you're getting when you go from distro to distro. Except, you know, in the Linux world, you have different desktop managers or just different desktops or Windows managers and things like that. I would say if you're very new to Linux, then, you know, Ubuntu, Fedora, Debian, those types of things are probably going to be the most straightforward, and then ease your way into things like your Gentoo's and your Arch Linuxes. Okay. So here we say, hey, Mixer, I would like to link a sync. Wait, why are you complaining now? Input does not have this field. Ah, crap. I know input does not have that field. All right, for now, let's just look at this. Okay. Are we compiling? No. Expected struct link found. All right, right. Okay. So we're just going to do this. Link. I think all of those are options, right? No. I'm going to make these options because in the future, it's going to be possible that we maybe have like an audio or video only thing. Pipeline, we're going to make that required. Okay. So here we're going to say audio, none, video, none, pipeline, I guess we need name too. Name test dot. I really don't like the string literal thing here. I wish there was something that, you know, we could put in front of it to say that, hey, I really want this to be a string. This just seems bleh. I don't like that. Linux from scratch. A really neat pattern with option is temporary ownership via take replace. Yeah. I had looked at take a little bit. I didn't realize that you could do a replace though. Okay, so what's this? Help use struct literal syntax instead of pipeline. Oh, right. Yeah. Okay. So we're going to remove this. Okay. So at this point we have a link. We're going to return the link. Right? So do we force the owner to know about it, right? So somewhere we ask these things to link. All right, so let's do a little example. So we have an input. We're not gonna really worry about this at the moment, but fine. Okay, so right. All right, so here's like our little mini example. Oh. Mixer. Mixer. Okay. Output. Okay. All right, help a field in this name already exists. Oh, it's mixers, plural, mixers. All right. Just a heads up, everybody. It sounds like there is a freaking monsoon outside. So if I go offline, that is what happened. Callow, how's it going? Welcome, welcome, welcome. I don't think I get to catch you very often in my stream. If you all are not watching Callow, you should. I am often hanging out in Callow's channels. I really enjoy the stuff he does. The raid game is like my favorite game to play on Twitch right now. You know, Callow, I think that's why I watch other streamers, is just in the hopes that they raid you and I get to attack. Yeah, Callow and I are too. Even like non-technical streams, I'll run into Callow. Wait a second. Oh, because I didn't fix it here. Okay. Oh, you were lurking during the Docker Kubernetes AMA? Awesome. Yeah, Aaron and I need to do some more stuff on that. You know, like that's actually the world I've been in for the last 6 years. Is all Docker Kubernetes, building things in that space, you know, doing talks and workshops and stuff like that on it. So I really need to do more stuff on Twitch with that. But it's hard because like I don't want to do like workshop tutorial based things because it's really hard for people to jump in and out of. I don't know. I've collaborated with a few people to help them like containerize some things and stuff. Okay. So now we have this. We've got all of these things. We're pushing all of them. So now we want to mimic what. So we're going to assume all of these things are created. The app owns them all. That would be really nice. I missed Friday just to do another AMA. Yeah. So I mean, it's in the VOD, and I'll be uploading it to YouTube. But yeah, we can do more AMAs. We can do some stuff where maybe we bring guests on with their like Docker questions or problems, and we help them containerize their stuff. Yeah, impl into string is nice. What do you mean, Musin? Okay, so now, what did we implement this on? Mixer. So here, we're wanting to take our mixer, and we're wanting to link a sync to it, right? So here, what we're wanting to do is take our output and link it, right? Well, no, because we should be able to borrow this, right? I don't think we need to actually pass in this whole arc mutex anymore, right? Because we're not keeping anything from here, right? The trait sync is not implemented for output. Okay. Did I not do the impl sync? Huh, okay. So we need to do a impl sync for output, right? I started using into for parameters, and it's nice to be flexible, +1 for containerizing real world things. Yeah, because a lot of examples for containers are very, very, you know, minimal. And so when you start trying to get into containerizing apps that don't quite work that way, or apps that need to coordinate and communicate in interesting ways. I think that's where it sort of starts falling apart. Gallo, no problem at all. So if you have function impl into string, you can pass it a ASDF or string, or that can be turned into a string. Well, that doesn't work for the struct literal, right? Where I'm trying to create this. You find yourself still submitting up a VM. Hey, Ravenous, that is still a perfectly acceptable way to deploy things. Like, I think that people buy into the hype often and they adopt things, and containers and Kubernetes are a great way to solve Kubernetes and container-like problems. But with anything, it's cognitive overhead to learn and understand these things, how to build applications that way, how to manage all of the things that you install into your environment to support these types of architectures. And for a lot of use cases, that work and that effort is less than the amount of work that it's taking them to do it the way that they're currently doing it. And then there's a lot of environments where that's a lot of work for minimal gain or no gain. I mean, containers are a nice way for reproducible ways of doing builds, as well as like packaging and distributing applications with their dependencies. And you can adopt one without the other. Like you can adopt Docker without needing to go all the way to container orchestration, right? Calling toString or toOwned or string from has an actual cost, which is why string doesn't have a shorthand. Okay. So value is used here after move. Can't we just pass, like borrow it? Oh no, because it was moved here. It was moved there. So this is like just a really confusing use case as far as ownership is concerned. And this is where I start kind of going in circles. So we don't really need that thing. So now the question is, do I just ask output to create a link? Right? My concern really is, does this stop the pipeline? Because it's also possible that I don't really care what this is, right? Maybe what I really want to do is pass in this type. Right? You know, this might actually work. What if I did like a mixer.get sync or something? I don't know what we're gonna call this yet, but let's just assume that it returns me back a link type. So it's responsible for generating the pads and its own pipeline. Right? And then I could, in theory, say output link, right? Then the app would own all of the parent types, right? it would own the mixers, the outputs, the inputs. And then these link elements or link types would be shared between them, right? Well, so this works from an ownership perspective, but I'm still in the standpoint of which thing do I tell the output to unlink this? Who would have thought I'd spend an entire stream just trying to figure out how the hell we're going to lay this all out? It's confusing. So at this point, the app would need to manage all of these links though, right? Every link that's created. That's true. So we could auto increment the links. Well, I mean, the thought here would be that the link would have a name, right? And then we could also just, right? And just have a hash map U64 link and hand out a copy of that U64, which they can use to grab the link, remove it. Yeah, and so we sort of already have names, right? Right, because the mixer has a name, right? So in theory, the link object that it creates, right? We could use that to store it, and we could also make sure that that's unique, right? So we could get this to generate a, right. So if we ask the mixer for a sync, I guess it would get request sync, and this return back a link, right? Then inside of link, we would have all of the paths and the pipeline, which would be fine, right? So here, this wouldn't actually be generated here, right? It would be what comes in. Link. I'm gonna just comment this out. Just in case we need it. Okay. All right, so we could in theory get a copy of a link here, and then we could store link in hash map by link dot name, right? So then in unlink, it would just be something like this, right? So here we would just grab link from hash map based on name, unlink pipeline elements, something like that. Do you want to try to making that link name string more generic? What do you mean? Well, I mean, this could also be an answer, right? Oh, this isn't going to return back link anymore, right? That's going to return back some result or something. But for now. Fine. I'll implement interesting. Wise old bird, thanks for the sub. Okay, so this works from the perspective of some generic thing, right? So I ask the mixer for a sync. It gives me back that information, which I then use to pass into my output to link it. Okay. I guess here I would pass in a name. Let's just assume this is it, right? So that same name I could pass in here to unlink. And that's how we would be able to find the individual link. And we would be able to traverse the peer pads of this thing to find them on our side. Okay, so you're saying here would be impl. Wait, what'd you say it was? Into string. And so it would basically convert the type for me if I passed it anything that into is implemented in. Okay. So this would make sense, right? So grab link from hash map. Link points to pads on caller side. We need to grab the peer pad to find our side. Well, no, because we don't really care about our side. As long as we have their side, right? If we have their side, we can remove the request pad from their side. That disconnects us, and then we just have to clean up all of our own pipeline elements. So I think that would be okay. Aeoli, is it Eolios? Thanks so much for the follow. You wouldn't allocate a string to do a hash map lookup. Oh, you have to call into in the function. Yeah, okay. Okay, so this, I think, works so far as like calling conventions go. However, the only, I think, remaining problem that we have to figure out is managing. Ledger Leica, thanks for the follow. I think the only remaining problem that we have to manage is how do we manage these things, right? So where are all of these links stored? And our HTTP API is going to really break, right? Because we currently have like post. So we have like the notion of like mixers, inputs, right? And now that's going to now become slash inputs, right? So the difficulty we have here is this is actually like a post to mixers inputs, and this is how we're adding an input to our mixer. We're not going to have that anymore. So we are going to have to do something like, I don't know, post mixers links, right? Well, no, okay, so we could potentially fix this. Okay, so here's the thought, right? So right now, to mixers inputs, this endpoint is taking an entire input information, like the entire configuration for an input, So maybe that goes into /inputs, but to Mixer's inputs here, this just gets the name of an input now, right? I think that could work, right? Post Mixer's outputs. I mean, it might make more sense to do something like post links, right? And then this has some sort of like input name to output name, right? So effectively, this would be like some sort of JSON body that looked like source input name, right? Out sync, I don't know. We can call it input output source sync. We probably should figure out our naming conventions here. But so in theory, we could have some sort of JSON that looks like this. The difficulty though we have here is, how do I know what type this is? Because for inputs and outputs, this makes sense, right? In the current implementation, this would be fine, right? So the source we would always look for in a collection of inputs. The sinks we would always look for in a collection of outputs. But this all breaks down when we talk about like WebRTC, right? So WebRTC creates a unique situation because which one of these things is it? You know, I think that we end up needing an entire separate endpoint to manage WebRTC, right? I think that this is where we would create like a new WebRTC session. And then we would need a way of being able to link that WebRTC session to something else. So the only the only other thing that I could think of here is if we managed things like this. Inputs, outputs. So these are sort of all of our types, right? I'm just gonna remove these. We don't really care about what HTTP action. Okay. So the only other way we could do this is if we say like inputs thinks, right? So this is how we would attach something. And then maybe it would have a type. I don't know. Type mixer. Or, you know, WebRTC. And we could do the same thing here, right? Sources. And this type parameter would tell us where to find it. The other option would be if we took WebRTC and WebRT was something special where some shared value is held between two pieces, and we have like almost like a pipe where we have the input side and the output side. And when you create a WebRTC, it's considered both an input and an output, right? So if you gave me the name of a if you gave me the name of a WebRTC session, then I would be able to, based on its current context, know what you meant. Like which side you mean, right? If you're adding it as a source, then I know that you mean the sync side. I guess a third or fifth or whatever number we're up to option here would be is if we just had a generic element, right? And then we're trying to link two elements together. I think that might get really confusing though. I do want to make sure that we solve for this case though, because that's like one of the whole reasons that we're doing this refactor right now. All right, let me use the restroom real quick. What is the difference between WebRTC and RTC? I think RTC is just one of the protocols that WebRTC is built on, right? So there's a few kind of underlying. So was it RTP and RTC are the ones that WebRTC is based off of? Nope, that's not what I'm looking at. WebRTC, RTP. So I think it's just the transport that it's using, RTCP. Yeah. So it's built off of RTP and RTCP. One day it would actually be really cool to implement one of these, but that would be really time consuming. Okay. So we still just have to decide on what this looks like. It's really great at implementing protocols and parsers. Yokoli, thanks for the follow. Okay. So I guess once I figure out what exactly this looks like, we could start. I mean, I don't. We're not going to have time to make it very far this stream, but we could start implementing this. So which of these makes the most sense? I mean, internally we could have a hash map, right? A hash map of string element, right? And an element could be in enum, right? And maybe that's how we manage it at the application level. So the thought here would be that we could match on the element type, right? So if you tell me to like / link two things and you give me source and sync, right? Let's just, that goes out of the way. Let's just say here, you gave me source and its name, right? This would be input name, right? And then you gave me sync, and this would be its output name, right? I would be able to look up by the name in this hash map, which would be hopefully unique. We'd force inputs, we'd force every element to have its own name. Then we could find it in here and we could match on its type, right? If needed. So I mean, that would give you a generic way of doing that. No, because so we still don't have a way of knowing all of the things it's linked to. Well, I guess we could maintain a parent type here that keeps track of all of the links it has so that you could ask all of the things that it is linked to. So Endofunctor 0, basically the issue here is that the current design of how all of these components work together is that there are inputs, mixers, and outputs. And right now, the mixer owns its own inputs and outputs. So there's two things that we're trying to do here. One is we want to pull those out, right? Because we don't want a mixer to own them anymore, because we may potentially want to connect an input to multiple mixers or directly to an output or things like that. So that's one issue. The other issue that we're trying to solve here is that now that we're trying to introduce the concept of WebRTC, is the fact that WebRTC becomes the first component outside of a mixer that can both be an input, right? So we could drag in, you know, somebody's video from a session. However, it can also be an output. So if we wanted to preview what's coming in on this input, then that could also be pushed there. Or if we wanted to send the output of the mixer itself to WebRTC, we could totally do that as well. So right now we're just sort of in like this test file that's smaller and trying to experiment with what does the abstraction look like now, so that we can kind of get into the bigger refactor of pulling all of those things out and deciding how to do this. So the new kind of concept, I think, is basically the inputs, outputs, mixers are all kind of owned up at the app level, because now we could connect directly to things instead of through a mixer if we wanted to. And then what we would do is we would ask them, say, hey, give me a link. And the link would contain it's the name you requested, as well as references to the audio and video pads. So that's sort of the thought here. And then internally, we could track a vector of our own links. And then unlink would just take the name to unlink that. So I think this makes sense for most cases. So now we're just sort of thinking out, what does the HTTP API look like for this? Because up until now, you would post to mixers to get a mixer, right? And then you would post to mixers, you know, mixer name. Well, here, we'll just say name, right? Inputs. And this would create the input and link it. But now we're in a situation where, well, mixers aren't the only things inputs can be linked to. So we're just trying to explore what this HTTP API might look like now that we have this notion of being able to create all of these things sort of independently, and then try to request to link them to each other, right? So now an input could link to a mixer, it could link directly to an output, it could link straight to WebRTC, right? An output, a mixer could link to send its data out to an output. I guess this would be sync only, right? But WebRTC could, one WebRTC item could both be sent into a mixer or out an output as an input, and at the same time have an input go to it. So that's really, we've just sort of made like this project a little more complicated in the way things are. And so I'm just sort of exploring what this API should look like. Like this part of it, I'm 100% okay with. I'm just trying to figure out, what does linking look like now? And so my thought here is that each one of these could have a distinct name, and not distinct based on its type, but distinct as a whole. And if that were the case, anytime, you know, we said input, name, and link, then this could be passed oh no, it's sync, right? So if we knew it was a sync, then we would be able to go fetch it out of output. I mean, I suppose the other thing we could do is just ask you what you want to link it to. We could say type, right? And I could say, I want to link this to a mixer, and this is the mixer name, right? Oh, I guess this would be links, right? So this is clear in this case, right? Because an input can only serve as a source, right? It would also work in this case, right? Right? Because we know that an output can only be a sync But for these two cases, it breaks, right? Because a mixer is both a source and a sink. So I don't know when you tell me to link this. Well, okay, that's not true. I do know that if you try to tell me to link... I do know that if you were to try to tell me to link a mixer to an input, I could use an enum or something there and know that what you really mean is that I should serve as a sink, right? And then the opposite is true. If you try to link the mixer to an output, I know that I should serve as a source. That makes sense. But what happens if I try to take a mixer and link it to a WebRTC, or a WebRTC to a mixer? Let's just use WebRTC first. Let's say I have a mixer set up with some inputs and outputs the same way we've been doing everything for the past couple weeks. But now I try to connect a WebRTC to the mixer. Then I don't really know, do you want me to pull, or do you want me to serve as a sink where the mixer is sending its data out to me and I'm pushing that out through WebRTC? Or do you want the stream of WebRTC that's coming in to go into the mixer as an input? So that becomes a bit unclear. I mean, we could do something like sources, right? Sinks. That would be clear, right? In the direction. Then I guess here I could do the same thing, right? Sources. So mixers is a unique use case because a mixer, as the pipeline is designed now, a mixer can have many sources as well as many sinks. WebRTC, is that also true? Well, sinks, yes, right? Because we would just put a T there. Because every input we should be able to send directly to some output or something, right? What about the other case? There's not a compositor there. Well, so I guess that's true for outputs too, right? Because an output currently can only be... So currently an output can only be fed from one place. So is this true? And that would... Well, no, a mixer can have multiple sinks. Okay. So this is possible. I do think that WebRTC is going to get complicated, right? Because in this case, I think we've handled everything, right? Like, I have the possibility to be able to create a WebRTC session. I have the ability to connect it, right? So yeah, so these are our two problems. So WebRTC, but what about multiple participants, right? This is going to get tricky because what happens if I want to send each person to a different place? So an example of this, a basic example of this would be, what if I wanted to record each participant separately? I mean, I would have the ability to do that. This gets super confusing very quickly. The other thing is we're going to have to figure out the fact that, well, when I link this source, right, this output source, it shows up in both these places. So we do need some sort of data structure where we have the ability to look up these. So if you ask a mixer about all of its sinks, it will tell you. If you ask an output about its source, it should be able to tell you. You know what? What if we removed that? Well, no. Because if I tried to like link this output, I might want to be able to hit the API and figure out what it's currently linked to. So this should exist. But maybe it only needs to exist from a get standpoint. But we're gonna have to manage some sort of data structure here that allows me to pull it both directions. There's a part of me that kind of feels like just starting with a new repo for this, because things are going to be so kind of drastically different in the way these things work. I really don't like this HTTP API. I can buy into the rest of it. This, I think, all makes logical sense, right? Give me a sink, right? But, you know, give me a source, right? It's gonna be a link on the other side. No. Other way. Does rewriting a Rust project count as rewrite it? My Rust code was terrible, so I rewrote it in Rust. Okay, so here we're requesting the sync pads that we're going to pass the output. What does linking an input look like? Actually, this is actually the wrong way, right? Because this technically would be request source, right? Because we're going to be passing a link into output. Output is the sync. It has the sync pads. We're linking it to the source pads of a mixer. GStreamer, you have to think about things separately, or in reverse, right? The output pads are a source pad because they're the source of the data. Okay, so here, I mean, we could do a mixer dot request input or request. I'm just thinking about how to manage all of these things. The other thing we could do is ask the input for them, right? Input dot request source, right? and this would return back a link. Then output dot request sync, right? Then I guess we could have a connection that has both sides of it, right? So this would be like source link, sync link. I don't know. I'm just experimenting with other ideas here. So this would represent all of the connections, and then we would have both sides of it. Then each side could be responsible for their own teardown. I have zero clue how I want to do this. This wouldn't be too bad, right? If we had this, right, then we could just link two things, a source and a sink, right? And then this hash map of elements could be all of these things, right? And then we could just match on them. And if you tried to link a source that isn't a source type, it would just fail. For me, this thing looks like a graph, and for graphs, I think it's always good to specify the edges. Well, so that's really what connect is, or connection would be, right? That would represent the edge. So you would have some element element connected to some other element through a connection, right? And so inside of that connection, each side has their own link, right? So I guess it's just a matter of figuring out what does this code look like now. So we have a connection. Connection holds both sides of the connection. So then would element hold connections, I guess? Just thinking about this. How many times am I going to do that? Okay. Yes, this is the Rust stream multiplexer. So we started introducing some new concepts, like types that could be both inputs and outputs and things like that. So we're sort of like backing up a little bit and trying to explore potential design of the internals of it so that we can support this, both from like a how do we implement it internally, as well as what would the HTTP API look like. So this is going to be internally. We're gonna refactor the internals. Who needs structs? Implementation blocks are overrated. Okay, yeah. So an element. Well, no, because an element. All right, let's All right, so we have a connection. A connection contains both sides of a link between source and sink, right? And we'll use these generically. That could be the same thing. So, but then an element can have multiple connections. Connections could be source, sink, or both. Sources, sinks, or both in the case of Mixer and WebRTC. Okay. So these are sort of like laying out what our types can be. So we have an input. Can be a source to sources of streams, and we have an output, sinks for data or for streams, right? And then we have a mixer, both an input and output, source and sink, and same thing for WebRTC, right? Okay. So this is sort of what we're dealing with. So we need to be able to create all of these types. Okay. So a mixer has multiple sources and at least one sink. So a mixer can also have 0 sinks. So we can actually, and we currently, the way the project works now, you can create a mixer and you can have it just sit there, or you can add an input to it and have it go nowhere. So that is quite possible. So mixers can have any number of sources and any number of sinks. Output, let's just do this requirement. So outputs can only have one source, cannot have any sinks, right? So data can only come in. Okay, so inputs can have any number of sinks, can have no sources. So a mixer can have any number of sources, can have any number of sinks. So WebRTC can have only one sink, can have any number of, can have any number of, other way around, can have any number of sinks, can have only one source, I think. So So a mixer has multiple sources and at least one. Okay. What's the concrete difference between a source and a sink? So a source is anything that data comes out of, right? So if we look at just our own pipeline here, right? So a source element only has a source pad. So data can only flow out of this type, right? And then on the other side, a sink only has a sink pad, so data can only flow to it. But we have some types, right, where in GStreamer world, they're referred to as filters. Okay, but in the compositor world, so we could have, here we could actually have any number of sync pads with multiple videos layered in. This only has one source, but our element types, we're actually making many to many because our element is going to wrap this whole part of the pipeline so that we can have multiple outputs on it. So WebRTC can only have one source. This one is going to be debatable. What about multiple participants? So I don't know what we're doing here yet. This type is probably going to have some special magic. But we need to get to here first in order for this to even be possible. Right. Yeah, so there is types, right? Input, output, and mixer are going to be actual types and connection. Element is just sort of a thought process I'm having where we could store something generically and talk about its things. Right, on these types there will be methods, correct. And there kind of is already. Right now we just have like link and unlink and some things like that in its current implementation. But right now, before we go through the heavy refactor here, I just want to rethink out this design because it's a massive refactor and I don't want to get like part way down it and realize that we actually can't do this, right? So I'm just sort of trying to think all of this out. And crazily enough, that's what we've been doing for 4 hours. Ah, software. Why are you so complicated? So I think we just have to think about what's the API look like. And I mean, I suppose this would all work, right? Some of these things would just be aliases, right? So if you came here to source, I might have to like go look up somewhere and figure out what you're connected to. But we could manage some internal data structures for this, right? You know, just double map entries where we put the link or the connection in the map for the output as well as for the input or wherever they're connected. Well, I mean, I guess so this is what makes Rust ownership interesting though, right? Because like if we wanted to be able to look both directions here in C or C++, right? Like we would be able to just do a graph where each thing could look across. Yeah, so that was the other thought, right? I think I was calling them names, but yeah, links. So that was the other thing, right? So we could do connections here and source sync. So the question that came from that wise old bird is sources and sync. How do I know what type you are referring to, right? So I don't actually know. Is source an input type and I should find it in the inputs vector? Or is source WebRTC? Or is it a mixer? So I don't really know here, and that's sort of where I was going at with this. If we could refer to all of them, right? And this was just an enum or something, right? It could be an input or an output, which I guess then in turn would be an enum or a trait. Then I would be able to just look up by name. And then we could guarantee that names are always distinct, that I don't care whether you're an input, output, mixer, WebRTC, a name is unique globally. Why do you want a connection and abstraction of the element it is feeding or being fed from? Alessandro, thanks for the follow. So the reason for that is because things can have multiple connections, right? So let's just let's draw this out. Let's go to Excalidraw here really quick, and we're just going to scroll down here, and we're going to look at we're going to look at like some concrete examples of like why this might be. All right, so let's start with an input. I don't know. Let's call this an RTMP feed, right? RTMP. RTMP. Okay. All right, there's like a mixture between dark mode and here that messes stuff up. Okay. So, we start with an RTMP feed. Okay. So this is going to be a basic example. So an RTMP feed is going to feed into a mixer, right? Okay. Okay. So we have an RTMP feed. We're feeding a mixer. So now we want to send this output somewhere, right? And I don't know. Let's just call this RTMP output, right? RTMP input. Okay. This is our starting point, right? Well, now we may want a couple of things, right? So what if I wanted to send that input or that RTMP input to multiple mixers, right? I don't know exactly why you would want to do this, but let's just say you did, right? You wanted to layer it in different places, right? Okay. But probably a more interesting use case of this would really be if I wanted to take this input and delete all of this and send it to a file output recording, right? So now that's going there, right? And I may want to do this for all of my inputs that I'm switching between, but for now we're just using kind of one example. Okay, so then up here, oops, what am I doing? 2. Up here we have kind of like WebRTC, right? I'm going to copy this, right? And I guess really this too. Okay, so here we're going to have this input also going to a recording, right? But it's also coming into this mixer. So they don't belong to elements. So that's sort of the problem now, right? Is before mixer is here. But so like here's another example, right? So now what if this WebRTC here, this could be an input, right? So this is a use case that we're trying to solve, but it's no different right now than this. However, this becomes an interesting use case. Now, what if this is running in the browser for our producer to preview inputs before they make them live? I might actually want to link this so that this becomes a sink and this becomes a source. So now that this is being sent to 3 places, right? It's going to the mixer for live, it's going to file output for recording, and it's going to WebRTC here, right? But then at some point, I may want to remove that link and switch it over here so that I can preview what's going on that stream, right? I may want to turn around and connect it to the outside of this mixer so that I can preview in the browser what's going out, right? So we just end up in this. Right. Yeah, it would exactly. It would be a studio monitor. However, the other thing is that we could end up in a situation where we want a WebRTC type connection as an input, where you go to the browser, you share your screen or your camera, and then we send that into the mixer as an input that we're switching between or doing picture in picture, right? But there may be another situation where WebRTC is actually going to come out here, or maybe both, right? Maybe this is a single WebRTC connection and you're feeding me your camera, it's going into the mixer, but I need you to be able to see what's on this person's desktop or this person's desktop because they're live and you're adding commentary, your voice or something is in there, right? Then you might actually want this feed coming out. I don't know. These are just sort of like, I want to make sure. So WebRTC could be an element type, same as a mixer. It's just unique in the fact that it can both, mixers and WebRTCs can be both sinks and sources. Whereas, you know, inputs and outputs, you can only flow one direction. But in this entire case, who owns this? Who owns the connection? Right? Before we had mixer owning inputs and owning its inputs and its outputs. But now that, you know, we may want to send this to multiple places, we really need to pull this up. So the thought here is that we're kind of just, oh, why do I keep pressing that every time I want to press 2? The theory is that, you know, there's a parent level, you know, the application kind of owns all of these connections. So that's sort of the thought, right? And I guess if we had a vector that contained all of the connections, then if you wanted to get a list of the sinks, then I could go to a hash map that looks up the connections for it. Yeah, the Rust memory management model, as well as like, who do we ask to link, right? So when I'm coming in here and I'm like, I want to connect these 2 things, who do I ask to do that? Who's responsible for it, right? Is the source responsible for connecting outputs to itself, right? Or is the sink responsible for connecting inputs to itself? Like, who owns that connection? And what happens when it's multiple kind of pieces? Not sure about you guys, but I find it refreshing to listen to somebody smarter than you on a subject and being exposed to new things, even if you're not grasping everything. What do you mean? Are you talking about me being like super confused by this? Me being smarter is arguable. So, Yeah, and I mean, sometimes we design complex software and, you know, we confuse ourselves by it and things like that. So yeah, I think the connection manager is going to be the way to go. Nimish, thanks for the follow. I think that the application is going to have to own some sort of connection manager to manage connections between things. I think ultimately that is the way that we have to go in order for all of this to work. The interesting thing is going to be, what does the HTTP API look like for this? I think the API itself would be okay. Because we could just have the application manage elements, right? I create an element of some type, right? I create an output, I create an input, right? And maybe these aren't even different. Maybe in the new design, we don't differentiate between input and output. Maybe elements are just elements, right? Maybe we just have a large batch of element types. And some of them implement, you know, a trait for source, and some of them for sync, and some of them for both, right? And so we could create these all outside of our application, and then we could add them to the application. Well, Mixer is going to own pipelines. Mixers are going to own the pipeline still. I think they're the only place that should own a pipeline. Ooh. So this is going to get confusing though too, right? Because what if I remove a mixer from the equation? What if I just create this RTMP input and connect it to this output? There's no pipeline. Right now, Mixer owns the pipeline. It creates the pipeline, it owns the pipeline, it hands it to the input and output when we try to add them to the pipeline and link them. This is going to require some more thought. Oh crap, I just realized what time it is. I gotta get off and make some kids some dinner. So I'm gonna sleep on this a little bit, and I guess we have this other side of this that we're going to have to figure out. Wait, where? Oh, here. We have this other side of it that we're without a doubt going to have to figure out. But let's raid somebody. And then we'll come back to this, I think tomorrow. I don't typically stream on Tuesdays. I without a doubt will be back Wednesday from, 12:30-ish to 4:30-ish Eastern time. Depending on my schedule, I have to look at what meetings I have tomorrow. I may be back on tomorrow to bang my head against the desk a little more on this. You could make it that all source connections are owned by the element, but sync connections are managed by the other side. Yeah, that does get interesting, though, for things that are both sources and syncs, though. Okay, who do we want to raid? We've got Vape Juice Jordan. We've got Anthony Writes Code. We've got CM Griffin. Does anybody have any preferences? Thanks for hanging out, everybody. This is a lot of fun. I'm really excited everybody stuck around and trying to talk this out with me. I know that these types of things are quite boring most of the time. I don't think I have ever rated Vape Juice. Let's raid Vape Juice Jordan. Unless anybody has any other suggestions. Just caught the last part of the stream. We'll try to get here earlier next time. Oh, no problem at all, JWL. Yeah, they're all the VODs are there, but I'll be back tomorrow. Hopefully. If not, Wednesday, definitely. All right, thanks, everybody.